Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my DIY water jet. This is episode, I think, 18. We might have a slightly shorter video today. It's already 12 o'clock at night, but I think we should have plenty of material to cover today. So I wanted to get all caught up, and also take a slight break from the DIY milling machine. So I'm going to talk a little bit about what all we've caught up to here, and also I have some new calipers for work that I'm going to be keeping in my work backpack, and then my other calipers are gonna have for home. So those are going to be my accurate reading calipers, and then those are the eye gauging Absolute Origin. I really like those calipers, but those are IP54. So I bought some shears, Ventor IP67 DPS, which is the absolute positioning sensor that shears uses. The other calipers are about $40. These shears are about about another $20 more. So it's like 60 but it's like 70, 60, something like that. I think it might be 70 for a 6-inch caliper, which is pretty standard. So we're going to use that guy there, and then my other set will be here. So I'll have my cheap Harbor Freight carbon fiber composite ones here for like, these are 10 thou, so we'll get a little bit better measurement. They seem to be pretty close, so that's pretty good, and they were really cheap. They were like less than $10, I believe. Harbor Freight, automatic turning off, automatic turning on. My other calipers, these new Ventors from Shars, S-H-A-R-S, Aventor, A-V-E-N-T-O-R. I wouldn't recommend them yet because I just barely got them this morning. Anyways, these have an auto shut off and auto turn on. My eye gauging do not have auto shut off and auto turn on, so that's also going to be a little iffy for even at home because I forget to turn them off all the time, and all my other calipers turn on and turn off, but they'll work great for at home, and those are my favorite pair right now. So let's see if these Ventors are able to take that spot for me. So this is what we have updated. I believe I did not talk about this in the last one, so I'm going to go over it. So basically we're still setting up the hosing for our system here, and that is one of the main things left. Also, I made a mistake that the inlet and outlet thread are not the same. So the inlet and outlet thread on this pump are different. So I've been talking to one of their correspondents at Julier to get these two threads, and also I found out what the taper is on the inside. So the outlet hole is tapered, and the inlet hole is just a straight hole. So I don't really care about the inlet hole because we're just going to use a flare fitting. So basically, long story short, the flare fittings that I got that are around here somewhere, I don't even know where they are now, but maybe they're under this mess somewhere. But those are not the right taper already, so that's number one. So we could go from there and get the right ones, because I do have the right recording. I believe they are, I thought that they were 3/8. I think they're actually 3/8 MPT. I'll have to look, because I basically measured them with these calipers, these carbon fiber calipers, and got that. So also what I just got from the supplier, I got the diameter of this hole in here, and also the taper, because that's basically how we're going to seal, is we're going to jam this tubing down there and press up against that and get a mechanical seal. Hopefully that finish in there is nice enough. That finish in there looks a little rough, so hopefully it's good. So, and then on the other side it's just a small hole. So, and also I found out how originally you're supposed to seal on the cutting head. So we have both sides So the cutting head is probably going to need modification. The pump side, I don't think it's going to need modification. So we could get all these over to the Hawk supplier, Tim at the Hawk supplier. So let's go ahead and look at this here. So let's go ahead and show you the pictures here. I was standing over by the pump, remembering what all we found out. So I wasn't at the computer, that's why you didn't see anything. But let's look here at some of the pictures. So here, you can see I already circled it to show the supplier, but you can see basically in here, this is the outlet, which is the M15 by, he says 1.5, but he says 1.4, M14 by 1.4, which doesn't make any sense. There's no such thing as M14 by 1.4. There's such thing as M14 by 1.5, and I tried a 1.5, and the 1.5 is in there. I'm going to have to go inside my Harbor Freight, one of my Harbor Freight tap kits, and it has a pitch. It has a pitch gauge, and I'll use that to double check before I have it machined. So basically, what we need to do is this thread doesn't really do anything. It's just straight thread, so it doesn't actually seal. So what happens is you have to have a tube go down here, and there's actually a countersunk hole here, and so we need to go and seal around the side of the tubing needs to seal around this hole. And I believe I showed you guys inside of this water jet video. I'm pretty sure this last water jet video. Did I? Yeah, because I must have showed you in water jet. Oh, so this must be episode 17, not 18, but 17. So I must have showed you in that one. Yeah. Did I show you water jet 15? No. I showed you one of these. Oh, I showed you in water jet 14. So again, this is where is it? Right there. Right here. So you see here, this goes in there 60 degrees, and this hole actually happens to be 60 degrees. I'll show you guys talking with these guys. And 3.2 millimeters deep, that's plenty. I believe it's like 0.3 millimeters deep. So this should work with no modification. But the issue is that it's an M14 by 1.5. So the question is, can they get a gland nut with an M14 by 1.5? So we'll see. What I'd really like them to have is a. Can't believe they can't make a gland nut with an M14 by 1.5, or a 7/8. Actually, well, it's okay if they don't have a 7/8, because what I would like to do is I would like to have a 90 come off of this. Sorry, come off the cutting head and go out. So this. So anyways, but this on the pump side should work. Obviously, it's the wrong taper. Well, actually, so what this is going to do is this is going to go into our manifold. That manifold that we designed in WaterJet 16. In WaterJet 16, we designed the two manifolds, and then this end of the cutting head, this part that goes up to the cutting head goes in there, and it latches in. So that's a 9 by 16, and then we have two other 9 by 16s coming out of the two outlets, and then those are going to M15 by 1.5 millimeter, or M14 by 1.5, and then those have the same exact setup as this. So this is basically on this side of the manifold that goes in, and then this is coming from the cutting head, and then both sides in the pump. It should work on all sides. So that's great. Now, because we have this, and I'll show you guys basically what we have to go off of. So let's get rid of that. Let's get rid of that. Let's get rid of that. So basically, this is what that inside of that hole looks like. So this is what that is: 2.5 millimeter hole and 3.03 millimeter depth by 6 at the top, which is a 60-degree angle. So that's perfect. And then let's see what he said on the back side. So what we're going to do is we're going to design this whole thing We're going to design this thing and then send it to our supplier. And actually on the side, unfortunately, I did design something off screen, so I'll show you that as well. So here, diameter for big hole. Oh, diameter is big hole is 6 millimeter. Okay, so I thought that he meant different side. He says small hole is 2.5. I could have determined from there, but that's fine. Okay. Okay. Okay, and then another thing that's super important is he gave me the pump charts for the amount of volume that we could press. So this is in bar. So let's see. PSI to bar. And so basically what we need, if you go on the WardJet website, WardJet, yeah, Orifice, WardJet University Nozzle and Orifice. So if you go down here, WardJet University Nozzle and Orifice, and you go down here, it has a really, really nice chart where they have empirical data. And I made a mistake. We actually have a 5 thou orifice, and we have a 20 thou mixing tube. So we're actually slightly below the 3 times. And they do have a 15 thou, but it's for their other cutting head. Was it FQ Stream? Oops. Cutting head. It is their Dialine. Their Dialine cutting head is their that is their basic their upgrade cutting heads. So their higher quality cutting head is called the Dialine, and this is what it looks like here. And then this guy they have a 15 thou for this guy, which would also be kind of perfect. Yeah, and then they have here's an adapter. So pretty interesting. 2 more abrasive inlet, 3/8, 3/16 or dual inlet. Cool. So good deal. So we have a 5 thou and we're running 30 psi. So basically what we need to look at is we're running 30,000 psi, and it looks like that's 20,000, 2,000 bar. So 2,000 bar, and we have a 40 to 1 GD 400 to 1, so that's 400. So if I pump it 60 psi, I get 400 times that. That's 2,400 psi, right? So obviously you could press it higher, so maximum 3,200 bar. But it does not look like you basically have next to zero flow. It looks like inlet outlet, but I don't think it's a 3/8 outlet. Oh, this is out of I think the 2 outlets. I think it's a 3/8 MPT, the 2 outlets. Anyways, I mean the inlets, inlet A, inlet B. I think that's what that means, because the GD I believe is dual action. It's in that chat what taper what actual thread it is. So in this case we need 5 thou at 30 psi. We need 0.09, and this is in GPM, gallons per minute. So we need to go from gallons per minute to liters per minute. To liters per minute. So gallons per minute, liters per minute to gallons per minute. So what we need here is at 0.530, we need 0.09. 0.09, which is, 0.09 gallons per minute. 0.09, which is 0.34 liters per minute. So you can see here at 20,000, we're definitely not doing 34. So we're going to have to drop the PSI down to about 1600. Oops, 1600 bar. So that's 23,000 psi. At 23,000 psi, which is like in between here, so we could say 0.075. 0.075. We need 0.28, and we're at 1600. 0.28, which is really, really close. We need to probably even drop it down further. It's probably in between these two. So that's 1500 bar. It's about 2200. 2200, that's closer to this, so I'm going to say it's about 0.072 or 0.073, 0.27. So 0.27 at 1500 bar. I would say we're there. So that's probably the maximum that we could operate. So one of the ideas is that if we have the intake not coming from the line, and we fill this this tank all the way up, and then we have the inlet all the way at the bottom, that will increase the pressure that we have on the actual incoming water. So basically, we bring that pressure back in, because let me see. What pressure is water coming into the house? It's between 30 and 80 psi. So the question now is, can we get it between 30 up to 80 psi coming inside the house? And let's see. What does it say here? So it looks like this guy's got more than 80 here. So it looks like he's going a little bit over 80. So we have to, if that tank method's got to go over 80, that'll be a big deal. The other thing is that if I could pump more psi, if I could get my compressor to pump more psi coming in, then also we'll be better off that way and get better out of the pneumatic pump. And then hopefully we get slightly higher flow rates, but these are pretty much tested, so we probably won't. So we're going to actually run at 2200 something. If we could up the pressure that I could push out of my compressor, and also increase the pressure to maybe like 120 coming out of my coming out of the tank, then we should be in way better shape. So let's see. We'll have to do some calculations in another video. If we have once I think that we have enough information to do another video, we will do that. In the meantime, I'll keep doing the DIY milling machine. But this, hopefully, we get enough data here that we could get started on having these hoses manufactured. So this is very important. Cutting head. Okay, so now we have the idea. Basically, we're going to need this guy here, which is 2700 here, 0.27, which is about 1500 bar. 1500 bar, which is about 2200 psi. And then if we could increase the psi on both the compressor and also incoming water, we should be able to get higher outputs. But basically, this is already incoming from the compressor. So we're going to need both to bump up the compressor and incoming water pressure in order to get the really high flow rates that we need out of this orifice. Or the other option is that we have to jump to a smaller size orifice, 0.04. And then that will be very hard to accelerate even 120 mesh garnet, which is basically what we're going to run. Most run 60 or 80, and we're going to have to run 120 in order to be able to accelerate it. I believe the Protomax runs 80. Protomax Waterjet. Protomax Garnet. Yeah, it runs 80 mesh. So we're gonna have to. So it runs 0.25 pounds per minute at 14-pound hopper. So it's about 60 minutes. Run for about 60 minutes, which would be great. That will do one whole shredder if that was the case. But obviously it's got only a 12 by 12 cutting area, so that you'll have to swap it out anyways. Okay, so we're gonna have to run 120 mesh because we have quite a bit smaller orifice. So now they have an 1/8 thou orifice and we have 0.05
5 thou. I thought we had a 6 thou, but we actually have a 5 thou, which is pretty good. So we could at least be in the higher range, 22,000 psi, if we can't increase all the other stuff. Okay, so there's that. That is done here. So you get the idea. This should be good. So if we have some time before the end of the video, we're going to model this. And then the other thing is this guy here. So this is the cutting head, and what you see is the orifice in here. So there's a shoulder right here, and then this is 7/8 by 18 in here. And I talked to the engineer at AccuStream, and what he says is basically what you have to do is you have to press the some sort of taper, some sort of stainless steel taper against this orifice. And this orifice has, from what I've seen, it has a 60-degree taper. I asked the engineer what it was, and he said that he couldn't disclose that information because basically they don't want people to copy it. But I mean, you bought it, so you could just kind of measure it. So yeah, I think it worked out. And you know, I come from semiconductors, so I know exactly what that's like. You can't disclose that kind of stuff. Yeah, so I asked him more about the dimensions of this thing and the size and whatever, so I didn't have to like measure it, but I measured it anyways, and now we have a good idea. So this has a little counter bore it goes into, and then this is pressed. The idea is that this is going to be pressed really, really hard by whatever you screw down in here and press onto this thing, that it will seal up. And so that's what the cutting head looks like, and then of course the two abrasives go in here. And so let me show you that model here. So, where'd you? Also, I'm really, really close to getting some of those shredders ordered. I hope to at least have it by Wednesday again. So here's the orifice that I modeled. So we'll see basically what I revolved here. This is what the profile looks like. So this is 0.22, and I think I measured this with a carbon fiber one, so I might want to measure it again with this Ventor, just to verify, because that's why these are in these kind of whole numbers. I might have brought my other calipers up. I can't remember. It looks like I might have. No, I think I measured it with these carbon fiber ones. That's why it's only to the hundredths thousandths instead, the hundredths place instead of the thousandths. But anyways, 0.22 tall. Oh, it's a 30 degree angle, sorry, not a 60. It goes down here, it goes down here, it goes down there, like that. And that's basically what it looks like. And there's kind of the mark of the hole, and then the 5 thousandths hole in it, right? It's actually 5 thousandths. Okay. So that's what that looks like, and then it goes inside of, where is it? Cutting head mock-up. So this is basically the cutting head mock-up. This is with, I believe I used my depth gauge and my other, I do have a little depth gauge thing. It's basically the same deal as using a caliper, but anyways. So yeah, it goes in here. 7/8 down, and then there's a shoulder. Obviously down here it doesn't do this, it cuts back again, and then there's like a taper down, but this is the same deal. So this has all the right distances and stuff that it goes down to the orifice here, and basically it's got a seal around this orifice. So this is the model that I sent out to those guys for the cutting head side, and basically it looks like it's going to work out for the pump side, but we need to model that to send them an idea of what that looks like. So let's go ahead and go to a new design, and let's call it pump side mock-up. Okay, obviously from the side that comes in from the cutting head, obviously it goes into the manifold that will be made, and again on the inlet side, I'm just going to have those two ferrules. Once I get the right taper, I'm going to have those two ferrules go in there. Oh, here's the ferrule. Where'd the other one go? Oh, here's the rest of them. So these are 1/2 inch, so I'm looking for some more 1/2 inch. I already have this 1/2 inch T. These came in from Amazon, obviously. I already have this 1/2 inch T, but
all the ones that I'm seeing now are like aluminum or whatever, and they do not have the 1/2 inch on the other side. But I'll find something on Amazon and buy it. And I'm trying right now. You cannot get the ferrule into the other side, but the 1x5 you easily get into the other side. So if I flip it over here, and I take this out, and then on the high pressure side, you easily thread the M1.5 by the M14 by 1.5. So I know for sure that 1.5 will work because the thread's down, but the thread, I don't know if you could hear that, but the thread is really, really loose. So that's why you have to basically create that mechanical seal by pressing it down. Alright, so let's pull out these Shars calipers. These have a pretty good action, but they have a little bit of a rough spot somewhere in the middle, so I think I'm going to put some silicone lubricant on here. And it automatically turned on for me. It'll automatically turn off when I put it back in. Okay, so it looks like 0.495 diameter. So let's go here. Let's do a thing here at the top. Circle. 0.495. Okay. And then overall depth. .94. This one, unlike my other one, did not come with the depth gauge adapter, so it's kind of hard. To get it to sit flat. I might have to bring my other calipers in with the depth gauge or my actual depth gauge. It looks like it's actually kind of crowned in at the center. It's kind of weird. I'm gonna say 0.6 with these guys. So let's go here, and then basically this is gonna be 0.6. So let's offset this guy. And this guy. So 0.6 depth, and outside, let's just make it. It's obviously a hex, 0.1059. 0.106. 1.06, and then what do I say, depth 0.6. 0.6. Alright, let's double check one last time here. Yeah, I would say 0.6 is good. 0.6. And that's 5 thou deeper than normal. That does not look right. Something does not look right here. 0.1065. Oh. There we go. That's better. Double check the inside. .0, I'm gonna say .490. Doesn't matter, we're gonna add a thread anyways. 490, 495, whatever. Okay, so that's good. And 0.6 depth. And then what we're gonna do is we're gonna show that last guy there. Oops. That last sketch. And we're going to drop this guy down. Minus 0.25, let's say. Doesn't really matter. Sketch. And then we're going to do a sketch on the top. And then we're going to open up. Oh, that's on that page. That's on this page. This guy, go to the other one. So this is the top. So the main hole is 2.5 millimeter. There it is. Punch it through like that, and then go over here and we're going to create, modify chamfer, and we're going to do angle, distance and angle. They have a depth and angle. 3.03 millimeters. Yeah, that's not it. So 3.03 is this distance here. So pretty much what I'm thinking is we're going to go to this. Or does it have it in the hole option? How far over are we? 32 minutes. Okay, good. So let's just finish this up. Create hole. And this we want to be countersink. Where's my last sketch? Create hole. And then this is 2.5. Distant millimeter. Through all. Countersink. How wide is it? 6 millimeter. 60 degrees. Boom, 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 boom. Boom, boom, 6 millimeter, 60 degrees, bam. Hide this. And that is the inside of our pump. Okay, so now let's create, obviously there's threads on the inside of here. So there should be metric. Should be 15, 14, 14, and 14 by 1.5, boom. And there it is. So that's it. Obviously this is hex, but that's fine. So this is the pump side mock-up, and that is it. Obviously this is different in here, but it doesn't really matter at that point. We just have to seal around this guy. And that is pretty much it. So now we have this guy, we have cutting head side mock-up, we have manifold mock-up for him. Also I want to add a pressure gauge on there, output pressure gauge, so I'll add a third. So there's 4 things attaching this thing. We have 2 outlets, we have a pressure gauge, and we have the main outlet. So we're going to have 4 things coming out of that manifold on this high pressure side. Then I got to get 2 ferrules, and I have a T. So then I need some 1/2-inch hosing, and then I need the blow-off valve. I need the blow-off valve and the air solenoid, the electric solenoid, and then I need the frame. Okay, so I think that is pretty much it. So we're moving forward, and this has been Steven from Legit Tech Tutorials and the Green Engineers, and thank you guys for joining me for my water jet video, my DIY water jet video. I'd like to thank you guys so much for watching. If you like this video, please subscribe for more videos like it, and I will see you guys in the next video.
Take it easy. Peace.